Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. And today, we'll be looking at differentiation, specifically the rate of change. This is part 10. And make sure to subscribe, like, and share so that you don't miss out on any of our future uploads, either on this playlist or other playlists. And you can check out the other playlists that we have so far: integration, polynomial division, quadratics, among others. Recall, from the chain rule, and this was differentiation part 3, we looked at other ways of differentiating, but today we are going to use that concept in order to find the rate of change. And take note, dy dx is equal to dy dt times dt dx. This is because the dt's can cancel out, so that what we have left is the dy dx. But there is no need for us to cancel out. We are just making use of the concept. Now, this would imply that the dy dt would be given as dy dx times dx dt, where the dx dt is given to be 1 over dt dx. Now, with that concept in mind, let us take a look at some examples. So, we have example 1. A point with coordinates xy moves along the curve y is equals to the square root of 1 plus 2x in such a way that the rate of increase of x has the constant value 0.01 units per second. Find the rate of increase of y at the instant when x is equal to 4. The solution. Now we know that we can express y as 1 plus 2x to the power a half. This is from the laws of indices. And I encourage you to check out our video on indices. We cover such content. Now, we are going to make use of the chain rule in order to find the dy dx from this y, because we need that bit. Right, so you can also check out part 3 on this differentiation playlist for more details. Right, as you would recall from part 3, differentiating such kind of functions or equations, we let u be the inner function, which is 1 plus 2x. Now, differentiating u with respect to x, we get du dx, which is equal to 2. And the second step would be y is equals to u to the half, because we have substituted for the inner function the 1 plus 2x. So we no longer have 1 plus 2x for now. Where we had that, we substitute with a u, implying that the dy du becomes 1/2 times u to the power minus a half. Then the dy dx becomes dy du times du dx. And with that, we substitute for the dy du, which we obtained in step number 2, and the du dx, which we obtained in step number 1. We are going to get dy dx as 1/2 u to the power minus half times 2. And of course, simplifying that and substituting back for u with the x plus 2x, we are going to get 1 plus 2x to the power minus a half. So that is our dy dx. Now take note, the rate of increase for x is dx dt. Remember on how we introduced the concept of differentiation, dx dt implies that x is changing as time is changing. So that is called the rate of change for x. And we're given from the question that the rate of change for x is 0.01 units per second. And in this case, it is the rate of increase. Now, that would mean that the rate of increase for y, which we are looking for, would be given by dy dt. Why? Because we are saying we have the change in y over the change in the time t. So that is what we are trying to find. Now, we have dy dt from the formula on the left-hand side being given as dy dx times dx dt. Now, we are going to substitute for the dy dx, which we obtained when we used the chain rule. So we are going to have 1 plus 2x to the power minus half times the rate of change of x dx dt, which is 0.01. So multiplying those, we are going to get that. And then we are told that at the point when x is equal to 4, so meaning that in that dy dt, we are going to substitute for x with a 4. Now, doing that, we are going to have that bit there. And of course, simplifying further, we are going to get our dy dt as 1 over 300 units per second. This implies that the rate of increase of y is 1 over 300 units per second. So that's how we solve such questions, and that's how we find the rate of change. Let us look at another example. A point P travels along the curve y is equals to the cube root of 2x squared minus 3 in such a way that at time t minutes, the x-coordinate of P is increasing at a constant rate of 0.012 units per minute. Find the rate at which the y-coordinate of P is changing when P is at the point 1 minus 1. And of course, the solution. We express y in this way. 2x squared minus 3 raised to the power a third. So this is from the laws of indices. Now, after that, we are going to use the chain rule. So from the chain rule, which we covered in part 3, so make sure you check it out for more details. We are going to use the substitution method or the chain rule in order to find the dy dx. Why? Because it's crucial in order for us to find the rate of change in y. So now we are going to let u be the inner function, which is 2x squared minus 3. And then that would imply that the du dx is equals to 4x. The next step would be to substitute for the 2x squared minus 3 in the y function so that we have y is equals to u to the power third. Now finding the dy du, this would give us a third times u to the power minus 2 over 3. Therefore, the dy dx is equals to dy du times du dx. Now we have obtained dy du from the second step. So substituting for that, we are going to get dy dx becoming a third times u to the power minus 2 over 3 times what we obtained for du dx, which was a 4. So doing that and multiplying, we are going to get the simplified version of dy dx becoming 4x over 3 times 2x squared minus 3, which was the u. Now substituting back the u, we are going to get that raised to the power minus 2 over 3. Now, you would recall that the rate of increase for x is given as dx dt, which was 0.012 units per minute. This is what we obtained from the question. And the question requires us to find the rate of change for y, which is the dy dt. Now, with the information that we have, we are going to find the dy dt by substituting for dy dx times dx dt. So we know what dy dx was, which we obtained using the substitution method or the chain rule. That was 4x over 3 times 2x squared minus 3 raised to the power minus 2 over 3 times the dx dt, which we were given from the question of 0.012. So now with that, we can actually move on to substitute for the x value. So now the x value is 1 because from the point P, we are given that the point has x coordinate 1 and the y coordinate minus 1. We are not going to make use of the y coordinate, so we just focus on the x coordinate, which is a 1. So now wherever we had x in our divide dt term, we are going to substitute that with a 1. So doing so, we are going to get that chunk here, and simplifying further, we get our answer as 0.016 units per minute. So the rate of change for y is 0.016 units per minute. That's how we solve such kind of questions. And if you have made it thus far, I say congratulations to you. I leave you with the following task. And make sure to post out more of such questions so that we get to have fun with these questions. And this is the purpose of having Numbers Simplified. Thank you so much for watching Numbers Simplified. And remember, God loves you.